Ladies and gentlemen, please welcome Milan Desai.
Good afternoon. Thank you. Thank you for being here with us today. We're going to spend the next hour talking about networking and security and how it can help you accelerate your digital transformation journey. Digital transformation starts with you, not your CEO, not your CIO, not the developer. It starts with IT. But why is it so hard for us to get started? If you look at where we are today, does this picture look familiar? It's the game of Tetris. And a lot of IT today feels like we're playing the game of Tetris, except we are not set up to win. What if we could change the game a little bit? What if, in the game of Tetris, you could pick your own pieces, and as a result, be able to build your own unique super Tetris? With this, we start winning, and in Tetris, if you're winning, the game never ends. So how do you do this? Where do you start? Folks who know me know I love to talk shop. But we're going to do something different today. We're going to have members of our customer community come and share their stories of transformation. We have an hour today, and an hour is not enough. So consider this the beginning of an engagement model with you to figure out with you what your unique super Tetris is and how and where we can start together. A common starting point for transformation when it comes to network and security is security. So rather than me talk about it, I want to invite on stage Chris from Interfaith to share his journey with us. Great to have you here, Chris.
It's great to be here.
So we were talking the other day, and you talked about how you were presenting at DEF CON around EMR and best practices. Could you give us a little more context on that?
Sure. Roughly 3 weeks ago, DEF CON occurred in Vegas, and I was here speaking about medical device security. It's been in the news a lot lately, especially with the St. Jude pacemakers. The Hospirit infusion pumps have all been found to be highly vulnerable to hacking attempts. And one of the things I was presenting on is the Security Society, OWASP, released some guidelines on securing medical devices within healthcare facilities. And I was presenting that particular security standard at the convention.
That's great. I'm glad somebody is thinking about protecting my medical health records.
Definitely needs to be done.
So with that, why don't you share your story with the audience here, your journey with security, and how you're transforming it in your environment?
Sure. It should come as no surprise that healthcare has been heavily under attack in recent years. Going back to 2015, the MIT Technology Review declared that 2015 was going to be the year of the healthcare hack. A look at 2016, we saw Hollywood Hospital and many other hospitals fall victim to ransomware. And even just going back a few months, we had the huge WannaCry outbreak, which brought the entire National Health Service of the UK offline. It also brought Erie County Hospital in upstate New York down for a period of 6 weeks. So healthcare has been heavily faced by a whole range of cyber threats in recent years. And there's a lot of reasons for this. Number one, healthcare contains a lot of very valuable data. If we think about what's inside our medical records, there's names, there's addresses, there's social security numbers, there's often credit card information, there's insurance identification numbers, lots of things that can be used for identity theft and fraud in a variety of different ways. This often makes these records significantly more valuable than stealing credit card numbers or other things. Stolen credit card numbers, you might get away with a few thousand in charges before the credit card company picks up the fraud and cuts the number off. Healthcare records, you can use them for all different types of identity theft, insurance fraud, and other things, and often ways that are much harder to detect. This makes them highly valuable. Valuable enough that they can fetch as much as 60 times the value on the black market as compared to a credit card number. And healthcare information can often be used in a lot of ways that we wouldn't normally expect. Like, for example, there's a huge black market for clean lung X-ray pictures right now. If you want to get a visa to come to the US from a country where TB is prevalent, they often require proof that you don't have TB in the form of a lung X-ray, and there's actually a black market for these lung X-rays right now. Now we combine that, we have a bunch of valuable data combined with an environment that often has a large amount of legacy systems. A lot of medical devices were built with patient care in mind, not with security in mind, but these devices are highly expensive and they're deployed to last in the environment for many, many years. So you might have devices that are 5, in some cases even 10 plus years old, that still function perfectly well from a medical standpoint, but from a security standpoint are often very poor. Any device that runs OSs that are no longer supported or software that's no longer supported, you have issues with being unable to patch the devices and the devices being left highly vulnerable. So this presents a big challenge. Okay. And then healthcare, like all other industries, there's always a huge problem with the employees themselves often being a source of insecurity. For example, the 2015 Verizon data breach report shows that 23% of recipients in a typical organization will open a phishing message and 11% will click on the attachments. Now, this is a pretty scary statistic because if we think about that, that means that in a phishing campaign of just 10 emails, there's a greater than 90% chance that at least one person in your organization will click that link or open that attachment, leading to the potential compromise of one of the endpoints in your environment. So this raises one of the big questions is, how do we take that compromised endpoint, assuming the compromise is successful, and prevent that from being used as a staging ground to compromise other systems within our environment? Now, one of the interesting things, too, in healthcare is I mentioned WannaCry a few moments ago, but WannaCry also presented a very unique challenge in that it was proven not just to take out PCs within healthcare organizations, but WannaCry also infected a large number of medical devices throughout hospitals in the US. Now, this creates a new, unique challenge, and it really gives a whole new meaning and whole inappropriate meaning to the term denial of service, because it creates issues of not just protecting the patient data, but also issues of potentially protecting the patient themselves. Now, a lot of these challenges are compounded by the fact that many hospitals focus very heavily on compliance, and compliance and security are not always one and the same. Case in point, we can consider something like the hack of TJ Maxx. It happened back in 2005. 45 million credit card numbers were stolen, and that happened as a result of the initial compromise of its wireless network. TJ Maxx used WEP, and if we look at the history of wireless, WEP came out in 2001. And sorry, WEP came out a few years before that, but by 2001, it was known to be flawed. By 2003, more secure replacement in the form of WPA was available. Now, TJ Maxx was compromised in 2005. 2 years after the more secure replacement was known to exist, and 4 years after WEP was proven to be insecure. Now, the scarier part about that, too, is it wasn't until 2008 that PCI DSS was updated to say that you could no longer use WEP and had to use WPA. And they gave businesses until 2010 to comply. So that's an awful long period of time in which you could have been perfectly compliant with the industry standard, but still pretty insecure. And we see that across the board, across all industries. HIPAA, for example, it's from 1996. It was last updated in 2010, and similar issues throughout other industries as well. Now, what does this all mean? Okay. It means a lot of the traditional approaches that we take to securing our environments are no longer going to be sufficient. If we take a look at a lot of malware that affects a lot of organizations, Verizon estimates that between 70 and 90% of the malware an organization sees is going to be unique to that organization. This means a lot of our traditional defenses, like antivirus and other stuff that relies on signatures or blacklisting, might not be sufficient to protect us against a lot of the threats we see emerging. So one of the things we really wanted to focus on is if one of these threats were to actually break out within our environment, what are some of the things we could do to prevent the lateral movement of that threat from one system to another system? How could we go about ensuring that a compromised endpoint did not lead to a compromise of the larger organization? And one of the ways we approached this is we started to use the NSX product to make a move towards zero trust. Now, what zero trust basically comprises of is it's basically you're putting a firewall in front of every device within your environment, and you're restricting network communications so that that particular device can only communicate with the other devices that it needs to within the environment and nothing more. So we're only allowing communications that are required for whatever system we're talking about to function properly, and we're blocking and denying all other communication. Now, this greatly helps prevent things like lateral movement by an attacker, because if two systems are not allowed to talk to each other, it makes infection between systems significantly more difficult. Now, this is a screenshot here of some representative NSX policies. And what we're trying to do is we try to lock down the communications so any particular system can only talk to the systems that it needs to in order to achieve its function. Now, how we went about doing this. One of the ways we started is we started with our basic infrastructure systems first. Things like DHCP, DNS. They're very well understood protocols. There's policies that pre-exist within the NSX product for allowing these network communications through. They're very low-hanging fruit. So we started with these first. It's easy to put the policies in place. There's not as much troubleshooting involved. It provides a great way to learn the product, start to get a feel for how NSX works. And with each system you secure, you are starting to improve the security of your environment. We then moved on to look at our VDI desktops a little. We do use VMware Horizon View within our environment as well. And once again, because these desktops are fairly standardized, each desktop's pretty much being used to access the same set of services within the environment. These also turned out to be fairly low-hanging fruit and fairly easy to configure policies on. We then took our legacy systems next, as well as some other systems that popped up in our risk assessments as being in the greatest need of security, and then approached those. And as we continued on with our deployments, we basically went up the complexity chain. So we started with the very simple systems that had widespread access and moved on to the more specialized systems over time. Okay. Now, zero trust, it's been highly beneficial to us. It's a great way to mitigate the spread of an attack throughout your environment. But one of the things to keep in mind is that as great as zero trust is it's not a panacea for perfect information security. Zero trust is one of a great many controls that can be used, but it should only be part of a larger defense in depth strategy and not the only control that has to be in place. So for example, if we put a firewall in front of a web server, that firewall may block whole certain avenues of attack, but it's not going to block an attack if the attack comes via port 80 or port 443, because those ports have to be left open in order to allow the web server to function. So zero trust, it's great, but only one of the layers that we need to have in place. So one of the things that we've actually been working on, we're actually one of the beta sites for this product, and one of the things we're currently working on implementing now in our environment is VMware App Defense. And what VMware App Defense does is it gets installed on the server and it learns the network-enabled processes that normally run on that server in order to create a baseline. So it learns what normally occurs on that particular service, what processes normally run, and what network communications those processes make. And then once you monitor the server for a period of time to learn the services, you can flip it on to the protection mode, and it basically at that point will prevent any network-enabled process from running that is not within this baseline we created. And this is one of the products that we're currently working on deploying now to provide an extra layer of defense for our data center for attacks that our antivirus, NSX, and some of the other security controls we have within our defense in-depth strategy will not block.
Thank you, Chris.
Thank you.
For sharing your story. Microsegmentation as a use case applies to all of us. And now, with tools in product like Application Rule Manager, using tools like Virtualized Network Insight from VMware, or third-party tools, it has never been easier to start your journey around security and microsegmentation. Chris pointed out the fact of defense in depth when it comes to security. Microsegmentation enables you to deliver a least privileged network. But he also pointed out how app defense enables least privileged compute. To get a little bit of a better preview into app defense, let me call on stage Tom Kahn.
Good. Thank you. Thanks, man.
How's this thing called sleep doing with you these days?
Security never sleeps, my friend. Never sleeps.
On that high note, I'm out of here.
Thank you, everybody. So, wanted to give you a bit of a sense of app defense. Obviously, Pat talked a little bit about this in the keynote the other day. Some of you may have come. We did a live demo, a live hack on an application yesterday. When the video of that will be up shortly. So, if you missed it, you can take a look. But to give you a sense of what we're trying to do. This is what an application looks like, right? It's a distributed system. It's a variety of machines connected together, networked together. And the thing that's really powerful about microsegmentation and NSX is the ability to create a logical boundary around that application, around that scope, and create a least privileged network to get rid of a lot of non-value added risk, to really go back to this concept of least privilege. With app defense, the question is, well, what about compute? What about the stuff that's running inside those machines? And if you look inside any one of these machines, what you'll see is executables, processes, operating systems. Some of these processes will be communicating and interacting with other processes on other machines. And in an attack, some of these very same elements are being manipulated. We'll manipulate a given process or introduce a new process, modify a process so it communicates to different things, such as a command and control server, or to move laterally in the environment. And the vast majority of the security industry has been focused on trying to identify and get better and better at identifying bad things. But it is a model of chasing threats, with somewhere in the order of 27 million various variants of threats and malware out there and changing every day. That's a very hard task to do. And we're flipping the model on its head to say, let's understand and ensure good. A model that's simply only about chasing bad will always be more expensive and less effective than a model that can start by ensuring good. And so how do we do this? We're doing this in a unique way that really leverages the unique properties of the hypervisor itself. And it really goes through three stages. A stage of capturing the intent of the various virtual machines and as they play a role in an application. Then the ability to detect in real time when a machine is doing something that's different from its intent. And then the ability to leverage virtualization itself to automate and orchestrate response. Now, the capture portion of this leverages the fact that from a hypervisor, we're in a unique spot to both see the running application as well as what was provisioned there in the first place. This is an important point because there's actually a wealth of information about your application that you're just not using today, you're not mining today. And so one of the first things we do with App Defense is we hook into vCenter and pull a full inventory of all the virtual machines in the environment. And then we start going after various systems that actually have knowledge about application intent already. Some of those are infrastructure provisioning systems like Puppet and Chef and vRealize. Right? That starts to give us some indication that, that machine over there is actually part of the database tier of this application and was supposed to have Windows 2012 on it. Then you start to crawl through systems that you might have, things that do application automation frameworks like Jenkins and Ansible and Maven. Now we can get visibility into, those are the packages that are installed on those machines. Those are the processes we expect to see. These are the communication paths those processes are going to use. But that doesn't tell the whole picture. And so what we do is we turn on a position that we have in the hypervisor to monitor the running application that may already be in production or maybe in a staging area, and we'll see sort of a wealth of behaviors and components. Some of those will be operating system stuff. Some of it will be things generated by security controls you may have placed on that point. And what the system does is sort of intelligently sift through that and pre-verify and validate significant components of that. Sometimes because we've seen it in blueprints and various authoritative telemetry. Sometimes because we've hooked into reputational feeds about those components. Or we've observed that same system or same setup multiple times in your environment or in other environments. There's a variety of methods to sort of pre-verify and pre-validate, and what you end up with is a very small number of unique components that an application team might have to look at and say, okay, yeah, that one is part of our custom piece that we built that does X or Y and Z. And what this initially does is create what's called an application scope, a birth certificate, if you will, for the application, one that we can maintain as the application updates. And we break this into manifests for every VM, a manifest that says, this is my purpose, this is the application I serve, this is my intended behaviors and communications. The second component we do is around detection. And again, we've leveraged a very unique property of the hypervisor that allows us, from the hypervisor host, to essentially create some things that allow us to create a little, what we call a protected zone, to monitor and look out over these manifests for each of these machines, as well as a process we've created to monitor the guest against the manifest in real time. Right? And part of the reason of this zone is one of the age-old challenges in endpoint security is if it's good and if it stops attacks, at some point an attacker is going to say, that's the thing that's sort of stopping me, and I'll try to turn that off. And it's very difficult to protect against because you're sitting in the same trust domain as the attacker. So the ability to watch over this is very, very, very powerful mechanism. So at the end of this, we now have a signal if what's running doesn't match what was intended. And the policy is quite simple. If what's running doesn't match what was intended, what do you want to do? And that brings us to response, where we can leverage the fact that virtualization is a highly automatable infrastructure, right? We can leverage ESX, NSX, even our third-party partners, to be able to create a library of automated and orchestrated incident response mechanisms. Suspend a machine, re-image a machine, block, alert, quarantine it with NSX, net block with a distributed firewall, insert full packet capture. Right? The key is, unlike a firewall, when you're dealing with compute, you need a graduated response, because very often the answer is, I actually need more visibility. And so the idea here is the policies are very simple. We'll help you figure out what its purpose is. And then all you have to say is, what do you want to have happen if it doesn't match? Capture, detect, and respond helps through an entire life cycle, not just in the SOC, but as you do rolling out or modifying applications for security review and readiness. You can get your arms around what I'm going to monitor, how we're going to protect this, as well as to detect and to respond to it. And one of the things that I think is most interesting out of it is not simply the technology, but the collaboration it enables between security teams and application teams, that they can actually collaborate in real time, that we're starting to say that's the alignment that's going to be so important. You know, traditionally security teams align with infrastructure teams. This is about enabling that collaboration with application teams. And in fact, we've built a mobile companion app for the application team owners to run on their iPhones and their Android phones that give them direct visibility into their applications. And there's a real-time connection and collaboration that can happen between security and them. Hey, your application is being manipulated. Are you guys in there? You want to take a look? Does this look weird to you? I'm about to do this. Does that seem okay to you? The ability to collaborate back and forth. That collaboration is key because security knows about threats and response, but the application teams know better about their own applications. And by enabling this collaboration, by embedding the knowledge of the application into the system, we create a very new model for security that's intrinsic, that is intent-based, and that is focused on good rather than chasing bad. Focusing on bad is often like finding a needle in a haystack. Ensuring good first means we get rid of most of the hay, and it creates a much simpler problem. You know, as it was said earlier, there was no panacea, there was no silver bullet for security. But ensuring good rather than chasing bad is an exercise of understanding and monitoring for 100 behaviors rather than 27 million pieces of malware. It can be a very, very powerful model. And if you'd like to learn more, we've had some sessions already. As I mentioned yesterday, we did a 40-minute live hack using our red team from our security organization That video is that, for those of you who haven't seen it, that video is going to be online shortly, and you can go take a look. There are some sessions later today at 4 o'clock. I encourage you to go. Chris Cord is running. Dennis Moreau has a fantastic session on Thursday. We have hands-on labs and demos on the booth. We encourage you to learn more because we think we've really, between microsegmentation on the network and app defense on the compute infrastructure, we think this is one of the most powerful advancements we can create in the security industry, and we hope you'll join with us on that. So thank you so much. And Milan, I return the channel command to you.
Thank you, Tom. Powerful indeed. 2,900 plus customers have started their journey with network and security on the VMware solution set today. It starts with, as Chris pointed out, visibility, applying the controls, and then knowing what's changing and being able to react to that change. The platform of vSphere, NSX, App Defense, along with our security ecosystem, truly enables us to be ready for this next generation of workloads that are coming at us. Now, we often talk about automation, and automation has different vectors. You can automate a piece of your infrastructure, you can automate your entire application, you can automate at scale, but how do you think about automation when you yourself as an organization are going through hypergrowth? What if you're a company that goes from Fortune 493 to Fortune 66 in 4 years and are dealing with scale and automation at that rate? Please let me bring on stage Joe from Centene. Hey, Joe. How are things?
Good, good, good.
So what does it feel like to be in this hyper-growth environment, Phone 93 to Fortune 66?
It's crazy. It can get really, really crazy at times. Very, very hectic, especially on the infrastructure side, as you can imagine. Adding capacity, patching, upgrading, it can get very, very hectic at times. But I like to look at it the flip side, right? So it's also very, very exciting. Working for a company, when I came to Centene in 2011, we were at 493. This last year it just came out, we're at 66. And just being a part of that organization and seeing that growth is very exciting.
It almost feels like you're working in Silicon Valley.
Yeah, I guess so.
So with that story, your story about automation in your environment, please take it away.
Thanks, Milan. I'm Jojo Sais. I'm the Director of Cloud Services at Centene. And Cloud Services is a fairly new department here at Centene. We are a traditional siloed infrastructure. We have compute, storage, network teams siloed out. So what we did about a year ago or so is decided, let's form a cloud services team. I was put in my position not quite a year ago, and I developed a team. I have 4 architects, and we recently added a senior engineer. Out of those siloed infrastructures, everybody had plans to get to automation, to get to that self-service, that on-demand self-service. It was on the roadmap. But as you can imagine, with that extreme growth, it's hard to dedicate people to a certain project, to say, hey, we're going to take you off operations and just focus on this. It's hard to do that. It's almost impossible. I was the network manager, and I could tell you, we were looking at NSX, and we were looking at software-defined networking, but we just couldn't do it. We couldn't dedicate the man hours to it. So we broke off a cloud services team. Now that team is responsible for implementing a software-defined data center. Out of the 4 towers of infrastructure, Centene's made some pretty good strides on the compute and storage side, and we're able to quickly deliver those pieces of the infrastructure. However, the 2 big pieces that we had left were networking and security. And we knew that when we could automate all 4 of those towers and deliver those as an on-demand service, that gives us the software-defined data center, what we're calling our Centene private cloud. Some use cases. What did we want to solve? At Centene, we need really need elastic capacity. We have seasonal business. We have open enrollment starting up here pretty soon, where we see a lot of traffic come in at the end of the year. We'd like to have that capacity expand out automatically. And even more importantly, come January, February, when that traffic dies back down, we want to be able to decommission that automatically and add those resources back to the pool and be able to use again. International market, we do have some international business at Centene, and one in particular is in the UK. The UK has a lot of different laws, and one is a data sovereignty law, where you cannot take data out of that country. So a use case for us is having a central management platform where we can deploy workloads to a public cloud within the UK, abide by those laws, and keep that data within that country. Automated infrastructure builds, that was the #1 requirement. Everything we build has to be 100% automated, not 99%, 100%. That does a couple things for us. It increases our security posture. It takes the day-to-day admins and engineers chugging away on those keyboards, removes that manual intervention, and gives us the same thing every time. So we know that if we have a golden blueprint, security has blessed a certain blueprint, that we can deploy that blueprint 150 times or 150,000 times, and we're getting the same thing every single time, stamping it out. Also, with 100% automation, and you'll hear me refer back to that 100% automation a lot. That was our main goal in determining what we're going to do with it. But we can take it and provide a self-service catalog. We use ServiceNow for that. That front ends that catalog for VRA. So we can have users, developers come into this catalog and have a sandbox where they can build environments and test, develop, innovate. The last one is software as a service and managed service offerings. We want to get to the point where we can offer options to our customers, where they can have certain parts of software. They can have dedicated hardware on-prem. They could have multi-tenancy hardware on-prem in a private cloud. They could have dedicated hardware in a public cloud. Bunch of different options that we can offer to our customers. And software-defined networking and security are the big pieces to enable us to offer that as an on-demand service. In our infrastructure, we use ServiceNow, like I said. When infrastructure requests come in, it's a workflow ticket. And at Centene, there's a possibility of 14 different tasks that make up anything we want to build. Depending on what you're building, if it's something pretty basic, it might only be 5 or 6, but if it's something more complex, it might not need all 14 of these. But when you can automate that and deliver that as an on-demand service, we can get to this cloud solution side and start to see the benefits of that automation. The two numbers you see here are based off of 2 different things. One is hardware, and I'll talk about the hardware in a couple slides from here. But the big number here, the big number that you see, is removing that admin and engineer chugging away on those keyboards, configuring those puzzle pieces together, in some cases, wedging those puzzle pieces together. Everybody's done it. I've done it. Remove that and repurpose that headcount to more innovative projects, to more projects that provide value to Centene other than chugging away on a keyboard. Benefits to Centene of our software-defined data center. #1 is security. Security is baked into this solution. Traditional infrastructure, we build infrastructure out and then we look at ways on how we're going to secure it. On this solution, everything we build has a security policy assigned from the ground up, has a virtualized firewall assigned to each VM. I'm going to go through a demo. It's a pre-recorded demo. Let me walk you through it real quick. Here's the topology of what we're going to show here. So if you look on that left side, we have a virtualized load balancer using NSX. We have 3 web front ends. And basically what we're doing, if you follow the black arrows, it's showing client traffic come in, and then the NSX load balancer will just round robin those requests. It'll go to web server 1, on to web server 2, on to web server 3. You'll notice each web server has its own firewall. We integrate that NSX firewall with Checkpoint. So let me show you something. You'll see here where you're simulating traffic coming in, hits web server 1, hits web server 2, web server 3. We are going to simulate compromising web server 2. What this is doing is we've compromised web server 2, uploaded some malware. Checkpoint immediately detects that, integrates with NSX, and applies security policies to quarantine that web server. At the same time, we are using vRealize automation and orchestration to build a workflow to add another host right behind it. So this has been sped up for demonstration purposes, but It's about a 5-minute process for that new host to come online. And soon you'll see here that Web Server 4 will be added to the mix. It says to not affect production. So when you think about that, and start thinking about this as you take this back home, we triggered that off of a security event. Checkpoint saw something, we quarantine. But we can err on the side of caution. If we see anything flaky happen, if we see anything that we're not quite sure of, we can quarantine and build right behind it. That normal process now is a long manual process to get that server built out, bring the effective one offline. We can quarantine these and have it only allowed to talk to some kind of security tool where they can get in, do their forensics, and determine what's going on. And we do not ever want that VM back. Destroy it when they're done. We've already built a new one. Next is business agility. Centene, as we talked about, has had rapid growth. A lot of it is due to M&A. Last year, we acquired a company called HealthNet. That company was about the same size as Centene. So let me show you an example. HealthNet has claims processing. Centene does as well. But what that is, basically, I'll run you through this, is we have doctors mailing in claims. On the other side of that, somebody would grab that claim, scan it into a database, and then we outsourced 170 contractors to manually read those in and enter in a claims file and send that off to be processed. What we did is we added some automation. Here, we added some optical character readers that automatically read those files in. It gets about a 75% accuracy. Then we can electronically send those claims off to be processed. What that did is we were able to reduce that outsourcing from 170 down to 15. $14 million savings per year. Now, where software-defined data center comes in play, or Centene private cloud comes into play, is we needed server builds here and here. Now, we did not have our private cloud in place at this time, so those server builds took 25 days. If we could reduce those from 25 days down to 25 minutes or less, that's another $1 million in savings in just this example. So having that agility, having that speed, and being able to react when we acquire new companies and we continue to grow is going to be crucial. New business, same thing. As we continue to grow and acquire new customers, we want to have that agility on the software-defined networking and security to bring those in rapidly and wrap NSX around things and protect ourselves from other customers within our data center. Hyperconverged, I said we put this team together about a year ago. I was put in my place. And since then, I've been meeting with our CIO on about a monthly basis. And one thing he said to me is, Joe, I want to get out of the building data center business. And I completely agree. In 2011, when I came to Centene, we were building a production data center. We bought the land, we built the building, we built a beautiful production data center. Very expensive, huge project for us. Since then, we've kind of refreshed or revamped a data center out in California. We've also kind of refreshed another data center in St. Louis that kind of holds more network telco stuff. But the production data center we built in 2011 was supposed to last us 15 years. We've outgrown that data center in 5 years. Last year, we just finished up another project where we actually a little more than doubled the floor space of our production data center, added Data Hall 2 onto it. So we feel like we've been building data centers almost every other year or so, and we want to get out of that. Hyperconverged is going to help with that. What we can do now in our current infrastructure in 5 racks, we can do in 2 racks of hyperconverged. So decreasing that data center footprint and slowing that process down as we continue to grow. One of the last things I'll share is on the people side. When we acquired HealthNet last year, we had to go out and hire 350 people to help with that integration project. Huge problem. We're calling it FTE avoidance. We want to avoid that as we continue to grow. Centene is not done growing, not done acquiring. So when we acquire the next company, we want to avoid having to hire so much. On the other side of that, we want to take our internal people and reskill, retool, become more infrastructure engineers. Like Chris mentioned or Matt mentioned about a data center engineer. And kind of retool them and get them reskilled around software-defined data center. The last thing I'll say is we are very excited about our partnership with VMware, not only what it can bring to our IT department and the changes that come with that, but to our business in general. Thank you.
Thank you, Joe.
Thanks.
Automation at scale, detecting issues in security, remediating that, and auto-scaling the app, right? That's a great story in production at Centene. Automation has different vectors, as I said. And Centene talked about a use case around IT automating IT, but we have folks like Amadeus who are doing this for their developers. And then we have folks like the California Natural Resource Agency, which is acting like a service provider to all local state agencies. Automation enables us to change IT from a cost center into a competitive weapon. And that's what VMware's solution enables us to do. That's what we can do together going forward. We've heard about cloud, right? There's so much conversation, from VMware Cloud on AWS to the public cloud. Another interesting starting point for a journey in network and security transformation is around a multi-data center, multi-cloud solution. DR, data center pooling, leveraging a public cloud is another starting point for your journey. To provide more context and share their journey with this starting point, let me invite on stage Matthew Wentz from State of Louisiana. Chief Design Officer.
That is correct.
How do I get that title?
You make it up. No, I'm joking. So it's actually a unique thing for Louisiana. So our challenge, we have several layers of customer. We have both the citizens of Louisiana, and we have our workers, our agencies. And so my job is to look across all of those different avenues and find ways to find synergy, to build systems together, to provide shared services. So really the design of our future platforms and systems.
I got to exchange notes with you. Get me that fancy title.
Yes, I'll show you how. So I work for the Office of Technology Services, which in Louisiana is the consolidated IT department. So what that means is prior to our creation, every agency, we have 16 of them, had their own IT, from maybe 5 people to 50 to 150. Each agency had their own mission, their own platforms, their own services, their own technologies. So after we consolidated, in one day, essentially, the law was passed and we were created. So in one day, we became the sole owner of all technology in the state of Louisiana. From people, systems, data centers, we have 2 of them. And so the challenge here is, now that we're consolidated, how do we actually make this a successful endeavor? How do we find opportunities for shared services? So we were fortunate enough to have a core customer in our Department of Health. And let me step one step back here and say, we're trying to build the systems of tomorrow. We're trying to build a shared platform for the state of Louisiana. And a challenge there is finding that core tenant. We can't do if you build it, they will come in Louisiana. That will never work. We don't have the money. And so to solve the money problem and to solve that first core anchor tenant, we were fortunate enough to work with the Department of Health. Now, they're responsible for overseeing the Medicaid program in Louisiana, amongst other things. But Medicaid touches about 1.4 million of our 4.6 citizens. A very big system in the context of our state. LDH works with Medicaid, the CMS, which is the Centers for Medicaid and Medicare Services, and they're essentially the ones who fund these types of projects. And they fund them at a 90-10 match, which for us means for every dollar we spend, we only have to spend 10 cents. So we saw both a core anchor tenant and an excellent funding partner here, and said, what we're going to do is start to build this new system. So how do we get there? So traditionally, we would have a 3-tier architecture, a single data center. We're going to build a system for Medicaid enrollment. Sounds great. Not really in line with where we're going for consolidation. What we wanted was to utilize both of our data centers, do it in an active-active configuration, highly available, always on. We're working for 4.9 reliability, which is largely unheard of in a state organization. On top of that, we said if we're really going to build a core technology system, we want to take advantage of public cloud. And we want to do so in a way that is really seamless. And so to actually build this, we looked at hyper-converged. I know Joe talked about this. For us, that's lowering our data center footprint. It's also giving us it's breaking down those silos internally. But we have thousands of apps inside of Louisiana, not just this one for LDH. So how do we actually build something for everyone to take advantage of it? And some of these are actually very old. We have some mainframes that are up to 40-year-old systems. So we have lots of challenges ahead of us. But now, I have a core system, I have a shared service platform, I have data center, I have 2 data centers, we're talking about cloud. How do we actually manage all of that? How do we get that to actually work? And this is really where the core VMware stack comes in. This is where NSX comes in. We talk about how microsegmentation and network overlay comes into play. Ultimately, what we do in Louisiana revolves around the context of data. Is it restricted data? Is it non-restricted data? We work with HIPAA data. We work with CJIS, which is criminal justice. We have federal tax information. Our customers are varied, and our data is as well. So we need to provide environments for this data to live, and we operate really in 3 major environments. We have a production, which is our restricted data context, a non-production, but also restricted data for things that are maybe test environments that have to operate on real data, and then for non-production, non-restricted data. So we built this using NSX, this microsegmentation, and enabling these 3 environments. And really, it's about the service that we're providing those systems and how they can utilize these technologies and these environments we've created. So I have Medicaid here as one, but we've noticed that as we've expanded out, this use case works across our organization. So we're talking with SNAP, which SNAP is the food stamp program inside of Louisiana. So between Medicaid and SNAP, it's about half of our state. Also, DSNAP, this is something near and dear to our heart here in Louisiana. It's our disaster response. It's the SNAP program for those people that are affected by floods, hurricanes, you name it. And one of the challenges here is for funding, we receive no funding to prepare. We only receive funding when something does happen. So turning things from a capital expense to an operational expense is huge. Providing these types of platforms, being able to seamlessly integrate with public cloud, this is where our DSNAP program sees a huge investment. Because now we don't have to worry about buying servers for the sake of having them sit there just in case we may use them, hoping we never will. Now we can deploy into the cloud. We can do so within the same context we're using on-prem. We're doing it across multiple data centers in an active configuration, which is great. I have a lot of technology now. But one of the challenges of implementing this, and I know Joe talked about it, is the people. How do we actually get this done? How do we break down these silos we used to have? And we still do. So we took 16 agencies with their own silos, and we created a large organization with its own set of silos. So we have traditional networking, storage, compute, you name it, across the board. NSX really starts to break that down. Now, this is our CTO has this quote, NSX was a wrecking ball that tore down those verticals. So I like to pretend that he actually did, just like Miley Cyrus, come in on a wrecking ball and tear down our silos. But really, this is the challenge, right? So we have people that are in place. They've been here for a long time. They've been doing the same kind of job, patching servers, you name it, provisioning. How do we start to get them involved? And we had questions like, hey, why are we using NSX? We're just using it for our data centers. We don't really need this. We can do it with traditional ACLs at our firewall, whatever. And we said, that's true. Today, we could do that. But for that next view, for that view in a public cloud, to treat that just like our own infrastructure, we have to make this investment. And that's when the light bulb went off. They said, okay, great, we really buy into this. We have 1 in 3 people in Louisiana can retire, in state IT, can retire today. So if I say something inappropriate and they leave, that's it, right? 1 in 3, that's huge. And it's very hard for us to recruit. So we want to bring in new technologies, we want to bring in new platforms to really encourage folks to come look at the state, what we're doing, giving them an environment to move around in, to develop quickly, to operate very quickly, remove these silos and actually prevent things from going over the proverbial wall. And it's really around that recruiting strategy and breaking down these silos that we're going to get there. Now I have the system, I have the people in place, but it's really about the next step. So I talked about Medicaid, I talked about SNAP, but I also talked about public safety, for example, driver's licensing. I have maybe boat registration in Louisiana, lots of fishing. We have tax, I have criminal justice. All of these systems have very common requirements if you look across the board. So how do we start to really look at that next customer? I talked about the anchor tenant in our mall, right? How do I get the next? How do I get even the kiosks? We have lots of various size agencies. LDH is a big agency. I think accounts for about 1/5 of the entire state budget. I have much smaller ones that have not the same budget as LDH. How can I give them the same level of service and the same systems, the same requirements to be successful? And that's really where we start thinking about tomorrow. So what's next? This force multiplier that NSX has given us, this ability to act fast, to be agile, enable our developers to build systems that can take advantage of this quickly. Traditionally, the state operates on maybe a 3-year procurement cycle, which is a challenge because if we start, let's say today, in 3 years, maybe 4 years, I have my system in place, I'm 4 years behind, which is an incredible amount of debt to incur every single time. So if I remove that procurement cycle, and now I can operate in a more agile world, I can give developers new opportunities to build things more quickly. We talk about the future, really, around DevOps, what that means from a CI and a CD perspective, how that integrates with our security testing, how that integrates with future services around maybe microservices, containers, Docker, Kubernetes. This is the future where we're going. Kind of how does serverless play into all this? We have strategies now to help us get there. From our on-premise data centers to our cloud stretch into all the public clouds, this is where we feel we have the most value. It's really at the developer, because ultimately we see it as citizens, our agencies, and then us, OTS at the bottom. But the real driver comes from our developers, getting them in with the citizens, getting them in with our agencies, building systems fast. We would never have been able to do that without the platform we built today, with NSX here, and really, like I said, second customer. We're always the next step, what's on the horizon. So thank you.
This song, the Wrecking Ball song from Miley Cyrus, we've been talking about this, right? So, this story, this partnership with the state of Louisiana has been extremely fun to be on this journey with them and drive the story with them. Changing topics, you consistently heard this idea of app modernization, DevOps, and driving that. And how do you drive that across any destination? And that's really what we're trying to do, which is wherever the application may land, we will deliver networking and security alongside that application. That is what we are going to do as VMware and NSX. Double-clicking a little bit into DevOps, app dev, Kubernetes, bring the buzzword du jour. What does all of that mean? How many of you here have shopped at Home Depot? How many of you struggle finding something in their aisles? Okay, that's me. Every time I go there, I struggle. It's an experience where I'm walking down the aisle, I don't figure it out. They're not staffed enough to help every customer walking in. It's not easy. Turns out, all of us have the same experience. So about the same time when I'm going through this experience with Home Depot, Amazon started selling more hammers than Home Depot online. Right? Now, it's not me that changed things, but I guess the competition did change things. And so 2 weeks ago, I end up at Home Depot with my wife. I'm looking for a basin for our garage. And one of the attendants said, why don't you download the app? So I download the app. It tells me exactly where the item is, the quantity of the item in stock, and it completely changed my experience. I was able to be self-sufficient, not walk around aimlessly through the aisles, and be successful in my Home Depot experience. That is what digital transformation can do. It can enhance that customer experience. It can make an organization more intimate. You can have that frequent interaction. That is what this app modernization, digital transformation, take the technology word of choice that you make, that is the world of change that we're seeing. And the big difference in this world is around the speed. Today, if you were to deploy an application, a traditional application, it takes us months. However, with this new model, you could have a piece of feedback on Monday, develop it as a microservice update to a piece of your module on a Tuesday or a Wednesday, test it on a Thursday, and go live Friday. This is happening at some of the largest organizations, not just the Ubers of the world, but in industrial organizations today in IT. And this is possible now with the things we are working on together. Whether it's a container as a service story, you heard about Pivotal Container Service today, or a PaaS story, we are natively integrated into these constructs. A VM and a container, to us, it doesn't matter. We will give it connectivity, security, and automate the heck out of it. The developers get the interface that they like. Full developer freedom. IT gets to control the policy from a network and security standpoint. This is something we can do together today. We can make your organization productive. We can get them digitally ready today, right? That's the story we bring together with cloud-native applications. In closing, I'm thankful, Chris, Joe, Matt, for sharing their stories of transformation. What you may have noticed is each one of them had a unique starting point and a journey which is unique to them with a destination that is unique to them. How can you get that type of flexibility when you look at a solution set? That's really how we think about the solution. By being infrastructure independent, you can start small, you can build it in the cloud, you can use it for some apps, you can use it for brownfield, you can use it for greenfield. By wrapping the security elements around the application, security is intrinsic to the infrastructure. And that by working across all compute and orchestration platforms, what you have is the ability to build your own super Tetris, start your own unique journey. So in closing, engage with us. How do you engage with us? Whether you want to start securing and automating your existing infrastructure, automate your greenfield infrastructure, deliver a multi-cloud solution, or be developer ready. We can do this today. You can pick your journey, you can pick your pieces to build your super Tetris, and we can start with you today. That's the power of the VMware solution set. As a next step, engage with us. Engage with the community. We will work together to start this journey of transformation in your organization. Thank you.